I would do sort of a casual introduction to artificial intelligence, and also how it relates to these other really popular terms that we're hearing. We're hearing out there in the tech space, machine learning, data science, and things like that. And these are all tools and techniques that we're using here at Life Epigenetics. And so I figured, well, it'd be a good topic for Webinar Wednesday, talk a little bit about what those are and how they relate to each other. So first and foremost, by way of introduction, so I am a new employee of Life Epigenetics, and if we go by the formal definition, our vision, Life Epigenetics will enhance the insurance and wellness industries with its proprietary breakthrough M-panel epigenetic technology, and our mission is to be the premier partner to the life and wellness industries for providing epigenetic testing services. Now, I promised we'd be a little more casual. So, the main two things I think to take away about Life Epigenetics is that we are an insurtech company and we make epigenetic tests, right? And we use machine learning and data science to accomplish that. I just wanted to point out our core team. I was very excited to join this team. We rounded it out. Now we're evenly tied between the doctors and the not doctors. So I think I'll leave the discussion of epigenetics and the details of that to Brian's webinar, and I'll focus more today on the machine learning side of things. So I was very, very excited to join this core team as the lead data scientist. Just a little bit about me. So I graduated relatively recently with a PhD in computer science. So for the past decade plus, artificial intelligence and all things related to it have basically been my life. Definitely watched a lot of Terminator. Very good movie series. And so my life has basically been delving into the details of what we're going to talk about today. So if you're interested, you can look at my website or just Google Randal Olson. So in addition to being an academic in a previous life at the University of Pennsylvania, I'm the lead data scientist here now, but also another thing that I've really enjoyed doing is, you'll see I have a link there to a blog, and on there I've really tried to find unconventional ways to make machine learning and artificial intelligence more relatable to people who don't want to spend a decade or more of their life delving into the details of it. So some of these you might have seen out there in the news talking about optimized road trips. How do we stop at every or at an interesting location at all of the 48 states in the U.S. in the fastest way possible? I've written a lot about how we can make those trips, how we can optimize them, and how we can make them fun. Actually, if we go back there, for a while, people were really interested in my solution to basically, if you remember the Where's Waldo books, where you open up this big, massive book where it's this big sprawling scene, a lot going on, and you're supposed to find a little Waldo character. I actually wrote an algorithm using machine learning to find Waldo as quickly as possible. I've done various data visualizations, analyzing census data, looking at racial diversity in counties, so on and so forth, and even looked at really silly things like who are the deadliest actors of all time. So basically there was a community of people who counted how many people actors killed in movies, mostly action movies, and I counted it up, and I had to find out who was the deadliest of all time. Arnold Schwarzenegger, definitely up there, very cool guy.
Who is the deadliest of all time?
It was Arnie, yeah.
Was that
well, at that time, it's surely changed now, and that comes with a bunch of caveats, right? Because how do you count if someone blows up a planet, right? How do you count that? Well, we excluded that kind of information. But anyway, so the idea of my blog and really my outreach there is to try to make data science and machine learning more interesting to people by applying it to maybe less serious things, but fun things, that can make you understand a little more of what's going on there. I also post a lot of this on Twitter. If you enjoy following Twitter, you can go check out my account there. It's Randal_Olson. I post a lot of similar things, not always made by me, but also just generally interesting analyses and projects. And also, I focus very heavily on on contributing to the open source programming community, and so I also have a profile on there where I've developed a lot of machine learning and artificial intelligence tools. Okay, so on to the actual topic we wanted to talk about today. So my goal for today is by the end of this webinar, you will know at a high level what artificial intelligence is, what machine learning is, and what data science is, and how they're different, right? Because oftentimes we will hear these terms and people get them mixed up, and people use data science when they mean artificial intelligence or vice versa. So let's delve into that a little more and what all that means. And also throughout this webinar, I will be pulling images from the web that I did not create, but I do my best to provide a source if you're interested in looking up where those images come from. Okay, so first let's start with artificial intelligence. So artificial intelligence at a high level, it's an umbrella term for the dozens of approaches to creating intelligent machines. So I think this graphic does a good job of explaining that, where let's see if I can get this mouse moving here. Oh, it's a little lag. There we go. Okay. Where we have several branches here coming out of artificial intelligence. So we have machine learning. That's what we'll be talking about today. We have natural language processing, which deals with how can a machine parse out text, either written text or even scanned text from images. We have vision research. So how can a machine take in a visual feed and process that in some meaningful way. Same thing for speech, planning, and robotics. There are actually a lot of interesting sub-applications that you may notice here. So for example, speech to text, that's heavily involved in Siri, right? Whenever you use Siri and you're talking to it, it has to record your voice and then translate that to some format that the computer can understand and process, right? Like for me, oftentimes whenever I'm writing a text to someone, I'll say, hey Siri, write this text for me. That's exactly what speech to text is. And so that is not necessarily artificial intelligence itself, but it is a component of artificial intelligence under that speech category. So I think one important takeaway here is whenever someone tells you, oh, we used artificial intelligence to solve some problem, whatever it is, you shouldn't necessarily accept that, because that's very similar to saying, oh, we used business practices to sell our product, right? It's very non-specific, and it's honestly not it's saying something, but it's not saying a lot, right? It's not being specific enough. So my recommendation is, if someone ever says, oh, we're using artificial intelligence, have them explain how and what kind, and hopefully they can, otherwise maybe they're just trying to swindle you. Now, all that said, this was a very popular tweet that came out last year, is, the way we use these terms varies depending on who we're talking to, right? This was very popular because it was a little controversial. They said, when you're fundraising, when you're trying to get people to buy in, you call it AI. When you're trying to hire someone, you call it machine learning, because that's what all the techie people like me love to do. And then when you're actually implementing it, it's some simple implementation that you program all together. So I think it is important to really try to delve down into those details, but realize that people will change how they talk about artificial intelligence depending on who they're talking to. So to delve into the second topic here, so machine learning, as I suggested with that diagram there, is a subfield of artificial intelligence that seeks to give machines the ability to learn to do something without manual guidance. So let's delve into what that actually means. And specifically, what we're interested in here at Life Epigenetics is this idea of supervised machine learning. So let's delve into what exactly supervised machine learning is. So the idea of supervised machine learning, which let's use a silly example, which if you watch the HBO show Silicon Valley, you might recognize, of we want to train a supervised machine learning algorithm to look at an image and tell us whether there is a hot dog in there or there is not a hot dog, right? So what we will do in a supervised machine learning sense is we have this machine learning algorithm and we collect a whole bunch of images, right? We'll collect a bunch of images of hot dogs with various different toppings, different orientations, maybe partially eaten hot dogs. We'll have a bunch of pictures of hot dogs, and then specifically we will put a label next to them, and when we feed that image into the machine learning algorithm, we're going to say this is a hot dog, right? That is the supervised part of supervised machine learning. By the same token, we're also going to want to get a bunch of images of things that aren't hot dogs, right? So we may get other foods, right? Like a pizza is not a hot dog, so we should feed images of pizzas in and say this is not a hot dog. Don't get that mistaken machine learning algorithm. Maybe shoes. I wouldn't. If I was hungry for a hot dog, I would not want to eat shoes. So the machine learning algorithm can learn to not say that that's a hot dog. And then maybe we can even get a little tricky, which I when I was looking for examples of not hot dog, this picture of a corgi in a hot dog costume came up, and I was like, I have to include this. It's just too cute. So we might get a little tricky and put something that kind of looks like a hot dog, but isn't, right? And we'll still give it that label of not hot dog. And so now we're challenging that machine learning algorithm to look at all those images and look at the corresponding labels and basically learn some mapping from that image to hot dog or not hot dog. Right, so in the sense, modern machine learning should be thought of as a tool that learns to produce predictions from data, just in the same way as this hot dog, not hot dog machine learning algorithm did, right? And so this is an actual app out there that they made for the Silicon Valley TV show, which you can download it onto your phone. I don't remember if it was made iPhone only. They probably made it for both iPhone and Android. You can take a picture of something and it will tell you this is a hot dog or this is not a hot dog, and it's actually pretty good at it. So I recommend checking that out. And then by doing that, you will be using machine learning. So now, of course, there's much more serious applications to machine learning than predicting what, looking at an image and saying whether there's a hot dog or not a hot dog in it. And that's a big part of what we're doing here at Life Epigenetics, right? So we're, in addition to specific information about people, whether it's there's a lot of information used in the existing underwriting process, whether it's driving records, financial records, health records, so on and so forth. We're bringing this epigenetics piece into it, integrating that, and making predictions about people's behavior and their longevity using these machine learning algorithms, right? So even though it's not pictures anymore, it might just be health record information or even just numbers, we can make predictions about, for example, whether someone is a smoker or not, and whether they're a former smoker or a never smoker. And same thing about whether someone is a heavy drinker or not. That's also quite relevant information. And so we really focus in on predicting behavioral traits that can be useful for the life insurance underwriting process. Now also another caveat to machine learning is that machine learning systems are only as good as the data they're built in from, or they're built from. Now, what you'll commonly hear from people in this field is, garbage in, garbage out. If you collect a bunch of nonsensical data and then, use the best machine learning algorithm out there, you're still not going to get very good predictions, right? So, in this sense, machine learning isn't a magic bullet for all problems. If you don't have good data, especially if you don't have high quality labeled data, you're going to really, really struggle with effectively applying machine learning in your domain. And so that's why here at Life Epigenetics, I'm very, very happy that we have Dr. Brian Chen working with us, because he and I like to say that we work together almost like a chef in a kitchen, right? Like Brian is the organic farmer, and he is producing the highest quality data with the highest quality labels. And we joke that I'm a chef, even though I'm horrible at cooking. But I can apply machine learning algorithms pretty well. And when you combine that together, you can produce a really high quality meal, or in this specific example, a really high quality steak, or high quality predictors that we're building as a part of Life Epigenetics. Okay, so the third term that I promised to go over for this webinar is data science. So another way to think about data science is that it is a practice that is focused on drawing insights from data using various techniques, right? And so there are many different key components of data science. You will have people that focus on data analysis, being able to take a data set and analyzing it, very similar to the way that I did with my blog post, right? Counting the number of kills that actors made in movies, so on and so forth. That's basic data analysis. Programming and scripting, being able to write programs that can automate otherwise laborious tasks. Statistics and how to properly design experiments to gather the data and answer the questions that you're looking to answer. Visualizing the data, so this is a network diagram over here, and this is an example of data visualization. How do we make the data more understandable? A component of data science is in fact machine learning. Some data scientists, after doing their data analysis and after setting up the experimental design, they will use machine learning algorithms to make predictions from that data, right? So machine learning is a tool that data scientists will use. And other things that unfortunately aren't commonly talked about with data science is having domain expertise. Wherever a data scientist goes, you want to have knowledge of what you're studying, not just the data, but the ecosystem surrounding it. If you're going to go work in a hospital and understand health records, you want to have a good idea of how that hospital system works and all the data that they're collecting. And then finally, probably in my opinion, the most important skill for a data scientist to practice is how you can translate a business problem into a data problem, right? That's probably the best possible skill the data science practitioner can have. How do I take this real world problem and translate it into something I can do on my computer? And I like to call this thinking like a data scientist. So to recap, since I've gone through a whole bunch of things in this whirlwind tour of these three terms, artificial intelligence is an umbrella term that encompasses machine learning and other approaches to creating intelligent machines. Machine learning is a tool. You should think of it as just a tool in a tool belt that produces predictions from data. And data science is a practice, or the practice, of drawing insights from data, and sometimes data scientists will use the machine learning tool as a part of that practice.